This is Algebra 1, Section 1.2. Now what we're going to be doing in this section is we're going to be looking at how variables fit into all of these operations and how we describe that verbally, which will be a major tool that we'll use in solving word problems, is to be able to actually verbalize what's happening in these operations. And they won't be very complicated today, but they will become more complicated, and again, to be able to verbalize what's happening is kind of the key here. So let's start by looking at the operation of addition. I'm going to put a dot to indicate that that's what we're doing right now. So we're going to look at an expression of addition that has a variable included in it and make sure that we know how to verbalize that in every possible way. So we look at the expression, say, 6 plus b. Okay, so that's one way that we can verbalize that, is 6 plus b. Another way that we can verbalize that is by using the name of the answer to an addition problem, which is called the sum. So we can say the sum of 6 and b. Okay? And a final way that we can do that is we can say b more than 6. Okay? Now, I guess the b's and the 6's weren't great choices because they look kind of similar, but you get the idea. Because we start with 6 and there's b more. After we add b, that's where that comes from. So these are the ways that we can verbalize an addition problem. Let's look at subtraction now. With subtraction, just like addition, if I write some sort of problem, say 5 minus a, well, that's one way to verbalize it. We've just done it. 5 minus a. So the next way is by same thing we did in addition, was naming the answer to a subtraction problem, which is called the difference. The difference of 5 and a. Okay, so that's a final, or a second way we can describe that. This is both two ways. We can also say a less than 5. Now with subtraction, it's a little bit different than addition. We need to make sure that, especially on this third way and this second way, that we make sure we keep our numbers in order. We have to say the difference of 5 and a to indicate that it's 5 minus a, and we have to say a less than 5 because we're subtracting a from 5. So that's especially important on subtraction and addition, but we'll hit on that again with division to reinforce that. Just keep that in mind as we go through these. Now let's look at multiplication and some ways that we can verbally describe multiplication. Now if I write a multiplication problem, say 7 times c, well again, we've already said 1, but I'm going to change one tiny little thing on this one. Now on addition and subtraction, we've used the specific variable name. We used a and b, but now instead I'm just going to say 7 times a number, because a variable is just simply representative for some quantity that we don't know. So we can say 7 times some number we don't know, just like we could say 7 times c. So a number and c are synonymous in this case. A second way that we can describe a multiplication problem is by using the answer, or the name of the answer to a multiplication problem, which is called the product. So the product of 7 and a number. And again, we used a number instead of c. So that phrase, or that wording, a number, means just the same thing as if we would have said 7 times c. It's just a little more vague and abstract. But either way is fine. You'll see both ways represented in your homework. Now let's look at some examples with division. Again, we said division was like subtraction in that the order of the wording mattered. Let's look at two representations for division now. We have 48 divided by x, and we have 48 over x. Now hopefully you know that these mean exactly the same thing, it's just different ways to write. Both of these mean see how many times x divides into 48. Both of these. So let's write out the verbal expressions, or the verbal representations of these. The first easy one would just simply be 48 divided by, and we could either say x or we could say a number. Let's use x this time. Okay, the other way is to use the name of the answer of a division problem, which is called the quotient. So we could say that either one of these expressions is also equal to the quotient of 48 and x. Now again, that we said that division, like subtraction, the order matters. We couldn't say the quotient of x and 48 and have it mean the exact same thing as what we've written here. Neither could we say 48 divided by x and have it mean the same thing that we've written there. So just keep that in mind, that the order, and again, in subtraction and division, is important to accurately verbally representing whatever math we're interpreting. Finally, let's look at exponents. And there's a couple of little, I guess, exceptions to the rule in exponents, and we'll deal with those first. Let's say we have a is the base and 2 is the exponent. The way that we would write that is either a or a number squared. I'm going to write a squared. So only when the exponent is 2 can we say squared. Okay, now an exponent of 3, let's say we had b is the base and 3 is the exponent. Well, it's similar to squared, except it's a different name. We would say this is b cubed. So an exponent of 3 means whatever the base is cubed. Now there's these are the only two exceptions that have a special name. So there's other ways that we can, or there's certainly other numbers that could be exponents. Perhaps c to the 17, or c and then the exponent is 17. Well, what we would say here is, and for all other exponents other than 2 and 3, is we would say c, or a number, either way, c to the 17th power. Now, there's one more thing that we'll look at. We could also have a variable in the exponent. What if we had 16 in the base, and then we had n as the exponent? Well, what that would read is, just like this example before it, look where the c is in the same place as this, 16 is in the same place as the c. So we'll write 16 to the, and the n is in the same place as the 17th, so what we'll say is the nth power. So whatever variable, it will be that, and then a th to represent it's some number power, like for instance the 13th, 14th, 15th, 27th power. We don't know, so it's the nth power. So these are all the ways, at least in this context, that we're going to be translating math into words and then words back into math. So we're going to be going both ways on this. So now you've seen an example of everything that could possibly come about in your problem set. And this concludes section 1.2.